Hello students, welcome back to my channel. Once again, this video I am going to explain preparation of ketones from aceto, acetic ester. So previous class we completed preparation of dicarboxylic acids, preparation of keto acids, preparation of alpha, beta and saturated acids. Hope you have completed noting down. If you haven't watched yet, please kindly check the video and complete your notes or try to practice the preparation of dicarboxylic acids. So with that, we completed acid hydrolysis under active methylene compounds, students. Okay, moving on to the next topic, that is preparation of ketones. Today we are going to learn preparation of ketones from aceto-acetic ester. So the basic one or the first ketone is acetone. As you all know, acetone is nothing but CH3, C double bond O, CH3. Okay students? Write down, please open your notebooks, put the side heading, preparation of ketones. Number 1, acetone, CH3, C double bond O, CH3. Okay, so do you remember the formula of acetic ester, students? Write down CH3, C double bond O, CH2, C double bond O, O, C2H5. So previously for the preparation of monocarboxylic dicarboxylic acids, that is under acid hydrolysis, the reagent used was concentrated alcoholic KOH. Okay, so there how hydrolysis has taken place we have seen, and you must also have learnt that one. Okay students, here under preparation of ketones, the reagent used for hydrolysis is dilute aqueous KOH. Look here on the arrow I have written dilute aqueous KOH. So when hydrolysis takes place in the presence of this reagent, so water coming out, water being eliminated minus CO2, that is carbon dioxide and ethyl alcohol. Previously, when concentrated alcoholic KOH was used, acetic acid and ethyl alcohol were coming out. Okay, but here this is carbon dioxide and ethyl alcohol. How hydrolysis has taken place and which bond is broken, I will show you students. So look here students, this bond is broken and here this bond is broken. So hydrolysis, hydrogen this side, OH this side. Okay, so CO2 is coming out, carbon dioxide. Next C2H5 OH is coming out. Now what is the main product that we are getting here is CH3, C double bond O, CH2, 1H is CH3. So this is nothing but our acetone. Okay students. So the basic part that we are getting from hydrolysis in the presence of dilute aqueous KOH is CH3, C double bond O, CH3. Okay, so this is very easy. The first compound, like under acid hydrolysis, acetic acid we have seen. Same here also, acetone, one step we will be getting the product. So here I have written CH3, C double bond O, CH3. Okay students, shall we move to the next compound? Yes. Second one, put the side heading ethyl methyl ketone. Ethyl methyl ketone. What is the formula of ethyl methyl ketone? CH3, C double bond O, CH2, CH3. This is ethyl group, this is methyl group. Okay, so ethyl methyl ketone. Fine, alphabetical order we follow. So that's why we named it like this, not methyl ethyl ketone, ethyl methyl ketone. How to prepare ethyl methyl ketone from acetic ester? Okay, so to start with, write down acetic ester, CH3, C double bond O, CH2, C double bond O, OC2H5. As I told you, in hydrolysis, after hydrolysis, we are going to get this portion CH3, C double bond O CH. What is the group attached here? CH3. So this group has to be introduced in esteroestic ester. So how to do that? First it is to be treated with sodium ethoxide. So one of the hydrogens from active methylene group and and OC2H5 ethoxide ion comes out as C2H5OH. This Na will be replaced in the place of the hydrogen which is coming out. Okay. So next CH3, C double bond O, CH, Na, C double bond O, O, C2H5. Okay students. Now this Na has to be removed and methyl group has to be introduced. Okay, so for that we are supposed to add methyl iodide. So this I and this Na will come out as minus NaI. Okay, so put an arrow and write down CH3I minus NaI. Okay, so when Na is removed, here CH3, that is methyl group, will be replacing. Next what comes? Write down CH3, C double bond O, CH3, C double bond O, CH. Now there is no Na here ma. So in the place of Na, there is CH3, C double bond O, OC2H5. Now comes here hydrolysis, dilute aqueous KOH. So what's being removed? CO2 and C2H5OH. So the compound that we are getting is CH3, C double bond O, CH2, CH3. So I will break the bonds how hydrolysis is taking place like we have seen in acetone. Same way here also it will be taking place. Okay. So you do hydrolysis on your own, students. See, here the bond is broken, here the bond is broken, HOH. So CO2 and C2H5OH both are coming out and the compound remaining is CH3, C double bond O, CH2, CH3, that is our ethyl methyl ketone. Okay students, so we are preparing ketones by hydrolysis in the presence of dilute aqueous KOH. Hence such hydrolysis we call it as ketonic hydrolysis. Like we called previously when acids were produced, we call it as acid hydrolysis. Here we call it as ketonic hydrolysis. Okay. Now you understood how to prepare ethyl methyl ketone. Now there is a homework for you or a practice question for you. Next compound, put the side heading methyl and propyl ketone. That means on one side there is methyl group, on the other side there is a propyl group. Its structure goes like this, students. CH3, C double bond O, CH2, CH2, CH3. Okay. So methyl and propyl. 3 carbons this side, 1 carbon this side. So methyl propyl ketone. Fine. Okay. So you will be doing on your own. Please try doing it, students. Don't neglect, so that it will be very easy for you to learn preparation of ketones. So you know on hydrolysis, this much portion till here we will be getting on hydrolysis. So to this carbon what is attached? Ethyl group is attached. So after adding NaOC2H5, the reagent that is to be added is CH3CH2I, that is ethyl iodide. Write down, students, that one. Ethyl iodide. Just I am giving you a hint over here. CH3 CH2I. Okay. So that is the reagent which you have to add after adding NaOC2H5. Okay. So this is about acetone, ethyl methyl ketone and methyl and propyl ketone. Next, fourth compound, methyl isopropyl ketone. So on one side there is, look here students, CH3, C double bond O, CH, CH3, CH3. So one side of carbonyl group there is methyl group and the other one is isopropyl group. Okay. So on hydrolysis, you know, we are getting CH3, C double bond O, CH. Till here we get. To this carbon what are added, students? This side 1 CH3, this side 1 CH3. So 2 CH3 groups are to be, we should introduce 2 CH3 groups. Okay. So what is to be added after adding NaOC2H5? 2 methyl iodides we need to add, so that here this carbon we can introduce one side methyl group and the other side methyl group. Ready? Okay. So write down CH3 acetoacetic ester. Put an arrow, write down 2NaOC2H5. Why? Because we are supposed to introduce 2 methyl groups. 2 hydrogens of the active methylene group should be removed. So 2NaOC2H5 minus 2C2H5OH. These 2 hydrogens, OC2H5 minus 2 OC2H5 minus will be coming out as 2C2H5OH. Okay. Next, CH3. C double bond O, C. Now there is no hydrogen here, there is no hydrogen here, Na, C double bond O, O C2H5. Now here comes, put an arrow and write 2CH3I. So 1I, 1Na, 1I, 1Na comes out as minus 2 NaI. Now here one methyl group is introduced, here one methyl group is introduced. Come, let us see the next compound. CH3, C double bond O, C, CH3, CH3, C double bond O, O, C2H5. So what are the groups that are to be introduced we have done. So next step is nothing but hydrolysis using dilute aqueous KOH minus CO2 minus C2H5OH. We are getting methyl isopropyl ketone. CH3, C double bond O, CH, CH3, CH3. Easy? So hydrolysis also, how it is taking place, I have shown here. Okay. So with this we completed methyl isopropyl ketone. Next, moving on to preparation of diketones. Put the side heading, preparation of diketones. What is diketone, students? It has 2 C double bond O groups. Look here, first example I have given 2,4 pentadiene. Here there is 1 C double bond O, here there is 1 C double bond O. So such compounds we call them as diketones. So number 1, preparation of 2,4 pentadiene. Okay, when there is only 1 C double bond O, we did not use di. As there are 2 C double bond O groups, we are using di. Why we are calling it as penta? Total how many carbons? 1, 2, 3, 4, 5. Okay, so numbering 1, 2, 3, 4, 5. Second carbon, fourth carbon, there is ketonic group. Hence, it is 2,4 pentadiene. This is the way we name diketones. Okay, students. Now you can see here, till this portion we get from hydrolysis using dilute aqueous KOH. Now what is extra over here to this carbon? This group is being attached. CH3 C double bond O group is attached. Okay, so this group has to be introduced. So how will we introduce CH3 C double bond O group? Come on, let us see. Acetoacetic ester. Write down. To this we will add NaOC2H5. So one of the hydrogens is removed as minus C2H5OH. Next, here comes, in the place of hydrogen there is Na replaced now. After replacing hydrogen with Na, what is to be done? Put an arrow and write down this compound. CH3 C double bond O Cl. This is acetyl chloride. So Na and Cl will come out as NaCl minus NaCl. So here comes C double bond O CH3 group. Don't write here, students, CH3 C double bond O. We have to add this C to this C. Why? Because this chlorine, this bond is getting empty and here it is empty. So this C and this C will be linked to one another. Okay. So next is CH3 C double bond O CH. Look here, I linked this C with C double bond O CH3 C double bond O OC2H5. So the group which is required after it is being introduced, we need to do hydrolysis, dilute aqueous KOH. On hydrolysis, as you all know, CO2 and C2H5OH comes out and the compound that is formed is CH3 C double bond O CH2 C double bond O CH3 2,4 pentadiene. Okay, students, hydrolysis also I have shown HOH, CO2, C2H5OH coming out. Understood ma? 2, 4 pentadiene. Okay. Next, second compound under diketones, 2, 5 hexadione, which can also be called as acetonyl acetone. Why? Because I will show you here. Look ma, CH3, C double bond O, CH2, CH2, C double bond O, CH3. Okay. So this is one part of acetonic group. This is one part of acetone. So hence we can call it as simply as acetonyl acetone. Okay. And it is also called as, see how many carbons are there total? 1, 2, 3, 4, 5, 6. Where is this C double bond O group? Second carbon and fifth carbon. So 2, 5, 1, 2, 3, 4, 5, 6. Hexadione. Okay. Or acetonyl acetone. So one part of hydrolysis we get this group. Another part of hydrolysis we get this group. So how to do this? Let us see. Taking 2 molecules of ester. This is one. This is the second one. Adding 2 NaOC2H5. So minus 2 C2H5OH. One hydrogen from here, another hydrogen from here will be coming out, and it will be losing 2 molecules of C2H5OH. Next, what is formed? Check. CH3 C double bond O, CH, Na C double bond O, OC2H5. Next, CH3 C double bond O, CH, Na C double bond O, OC2H5. Next is okay, now these two should be joined together. So these two sodium atoms should be removed. To remove, we are supposed to add here I2. So 2 Na and 2 I will come out as minus 2 NaI. Okay, now this is empty here, this is empty here. These two carbons will be joined together. Look here, CH3, C double bond O, CH joined with this CH. So now these two have become one. Next, on hydrolysis with dilute aqueous KOH, 2 CO2 and 2 C2H5OH will be removed. See here ma, how hydrolysis is taking place. This bond is broken, this bond is broken. Here this is broken, this is broken. HOH, HOH. So the compound that we are getting is CH3, C double bond O. Look here. CH3, C double bond O, CH2, CH2, C double bond O, CH3. Total how many carbons? 1, 2, 3, 4, 5, 6. Second carbon and fifth carbon. 2, 3, 4, 5. Fine. That is nothing but 2, 5 hexadione. That is our compound, this one. Completed, students? Okay. So once you know how to do 2, 5 hexadione, you will be able to do the next compound, that is 2, 6 heptadione. Okay. That means there are total 7 carbons. So second position and sixth position there will be C double bond O group. CH3 1, 2, 3, 4, 5, 6, 7 ma. So second carbon, sixth carbon, there are 2 C double bond O groups, hence it is called as 2, 6 heptadione. Same like the previous one, you have to take 2 molecules of acetoacetic ester and then add 2 NaOC2H5. Next, what you are supposed to add ma? I will show you. Look here. One part of hydrolysis till here. Okay. Second part this much. So on hydrolysis we will be able to get these two parts. So what is there in between? There is CH2 group. Okay. So in order to introduce CH2 group, what will you add? CH2I2. I am writing here for your information. CH2I2. Methylene iodide. This is the reagent. After NaOC2H5 was supposed to add methylene iodide. Then 2Na and 2I2 will be removed and this CH2 group will be joined in between this carbon and this carbon. Please try, students. I request you to do it so that it will be very easy for you to learn preparation of diketones. So students, we completed preparation of ketones and diketones using dilute aqueous KOH. So this comes under ketonic hydrolysis, okay, under active methylene compounds. So we completed acid hydrolysis and also ketonic hydrolysis. Okay students, those who are watching for the first time, please subscribe the channel, like the video and share it with your friends. Okay, so meet you in the next video with a new topic, students. Take care.